Gonna do a quick introduction of you. So everyone, this is Dr. Megan Higgs. Um, she runs her own kind of data science consulting company called Critical Inference. But before that, she did a lot of work in statistics. She got her PhD in statistics, and she could probably tell you more about her career and stuff like that, or whatever she has prepared. Um, but today she's going to talk about taking a deeper look at statistical assumptions, which is obviously very important. A lot of you are either statistics or data science majors, so I think that you guys will find that pretty useful. So with that, the floor is yours.
Erin, can you just give me a little bit of like who's in the room, like how many people are there, and like can you show me
Yeah,
really?
so we got, let me see if I could turn.
If you can. It's okay if you can't, but
Yeah, we have,
I'm kind of curious. Okay. Just like a small group back
it
there.
is, yeah, it's
Okay.
getting near the end of the day.
Yeah. No, that's totally fine. I just wanted to have some visual um okay. So, well, I'll just say a little bit more before I start my slides. Yeah, really happy to be here today. So I love talking about assumptions. It's my favorite topic. Um, like Erin said, I got my PhD in statistics, my master's from Oregon State University, my PhD from Colorado State University, um, both with Bayesian advisors, actually. And then I went into a faculty position at Montana State University. So I'm still in Bozeman, Montana right now. I'm no longer in academia. I decided to try out different things as well. But I was a professor for 10 years, almost 10 years, and ran the statistical consulting and research services. So, kind of the statistical consulting center there. I come from a background from biology and other sciences, not through the math background. So, not through the math path, which is kind of important to kind of where I end up in what I like to talk about. So, okay, I'm going to go ahead and share my slides right now. I'm going to try. um, Not sure I can do the full full screen here. Just try. See if that works. Does that look good?
Yeah, yeah, that looks great. Yeah.
Okay, awesome. Okay, so are you still seeing me now, or is it just the slides,
I
the
think I can
audience?
pull you up. Uh,
Okay.
there, yeah, yeah, we could see you now.
Okay. Okay, perfect. Thank you. Okay, so today is just really all about kind of pausing from our usual dives into more methods, more newer, better methods, like really pushing on how what we're doing, and really taking a step back to think about like how are we doing this and what else should we be thinking about. So I hope it's like a little bit different. I'll kind of be saying a lot of I'll be repeating things in different ways kind of throughout the talk. So hopefully kind of resonate. Some things will resonate more with others. So yeah, pausing to take a deep look at assumption, a deeper look at assumptions. Hopefully we're taking at least some look already. Um, so this whole my first life experience where I really had to think about assumptions in a deep way. Well, it really hit me. Was actually my experience in basketball as a ninth grade, like my freshman year of high school. And I had this basketball coach who was his name was Mr. Bean. He was this enormous man with this huge booming voice. And for the first 3 weeks of practice, I was completely terrified of him. And he would scream at us, like, you know what assume does, right? And like every time I would go too fast and miss a layup or like whatever, I just tended to go too fast. And so this came at me a lot. Um, so he would yell, like, you know what assume does, right? And he would never really, he answered it like once, but and then stopped answering it. But his first thing, he was like, it makes an ass out of you and me. And it was just like this, like full on intense experience that I has stuck with me. And you know, you never know how those experiences are gonna um, come up later in professional life. So, and I think, well, so Mr. Bean's message, I mean, obviously it's clear in basketball, but Mr. Bean's message for data analysts, to me is really to like slow down, really slow down, take these pauses and interrogate the assumptions that we're building all of our inferences and conclusions on. And so, and really it is to avoid making asses out of ourselves and our collaborators. And I think one thing that relates, so Richard Feynman, in a couple of his, in a lot of his talks, actually, I think really makes a big deal out of like, as scientists, we're trying hard not to fool ourselves. And we are the easiest ones to fool. So just that really like, just remembering how easy we are to fool, and that a lot of this like has to, a lot of deep work really should happen around trying not to fool ourselves, not make asses out of ourselves. So this was just like a really kind of quick thing I put together, but I think it's really helpful to think about levels of interrogating assumptions, just to kind of give us some context about kind of what I mean by deep. So in this figure, the top is shallow and the bottom is darker, is deeper. So like we have our stating mathematical assumptions like normality, linearity, IID. So all of the things that you would learn in just kind of your usual first stats classes. There's usually not much depth to it, right? It's like you just write them down in your like math stat course. Like a little bit deeper is checking those mathematical assumptions, but usually this is like maybe in a pretty automatic way. Can be using other statistical tests that have their own assumptions, but makes it seem like it's like this easy thing to do. I just run this test, look at the p-value, and say whether my assumption is met or not. And then we have kind of checking at mathematical assumptions in a deeper way in terms of thinking about like, okay, how severe are the assumptions? And maybe like independence is a good one to think about, because there's not usually a really easy way to check that. So you've really got to think about the context of the study design. So you're like starting to get a little more deep in there. And then I guess another layer is just like considering additional foundational assumptions that sometimes get totally left out of like homework assignments for sure in graduate school, right? So the fact that we're going to model using means, like we don't have to model using means in some cases, or based on means, that there was maybe a common treatment effect for all individuals, issues with measurement, issues with sampling, generalizability. So this list goes on and on and on. So even this depth is really just an acknowledgement that we have all of these other assumptions, right? Which is really important. And then can kind of even go much deeper in terms of assessing sensitivity or to results, or of results to violations. So this is kind of like you're actually thinking about like what's the validity, how are violations of my assumptions affecting the validity of my model and results in a more formal way. And then finally the last one I have is just like really considering doing the hard work, which we'll keep talking about, of how violations of assumptions ultimately affect inferences and how trustworthy our results are. And this like takes a lot of context. So it takes context around the models that we're using, understanding all the assumptions, and it takes the real scientific or problem context that's there. So just to kind of give you an idea of what I'm meaning by depth. And so those deepest levels really connect to some big questions. Like, are people going to trust or rely on the results too much? Like that's something we've got, I mean, yes, this happens all the time. And so it's something we need to start kind of asking ourselves more, especially when we're the ones presenting results. And like, what are the potential harms of that? Like really thinking through downstream results of that. Of course, in a homework assignment, like, it's not that going to be that big of a deal, but as you go out into the more real world work you're doing and decisions you're making, the harms are sometimes rather large and we're not really thinking about them. Yeah, and to what extent are results based on information in the data versus information inserted through assumptions? Okay, so I just like want to pause here. Like this is a huge question that is it's almost hard. It's so uncomfortable, I think, to actually really sit with the first time that it's hard to take in. And it's still hard for me. Like after like 25 years, I'm still like, oh, it's just, So to what extent are the results based on information in the data versus information inserted through assumptions? So all our results that we're turning out through statistical methods or any machine learning or AI, like they are a combination of information from data and information from assumptions. And I think what I go through today, hopefully will kind of help think through that a little bit more. And I guess like in line with that, like just keeping in the back of your mind, like if you take nothing away from this talk except for this like phrase, like assumptions are not free, right? They are not, they shouldn't be free. We treat them as if they are free, but really they do come at a cost. We just are really poor at acknowledging that cost in our current way of operating. So really thinking about assumptions as added information beyond that contained in the data. As this like combination, results as this combination of data and assumptions, as I said on the last slide. And then, just like put the question out there, like how different is relying on uninterrogated assumptions than throwing up made up data into the model? Right? Like you could make an argument that there's not much of a difference between those two things, but of course you would never throw made up data into the model, feed it, but yet we rely on assumptions without interrogating them all the time and really thinking about how much information is there. And Erin, feel free, anybody's welcome to ask questions anytime. So yeah, just interrupt me or whatever, anytime. Okay, so yeah, if there's a cost to assumptions, like we should be have to purchase in some way something to use these assumptions, right? So when we collect data, like data are resource intensive, like often take a lot of cost and time, effort to collect. So there's a clear cost to them. But assumptions, not so much, right? It's like we can just grab them and use whatever we want to and say what we're doing. So like really a question that I'm trying to do more work around is like really where in our workflow, like where in our data analysis workflow do we have a checkout to like actually purchase those assumptions? Like where's the purchasing step in this whole thing? So and really where I've landed in that, which you'll kind of see, is like this purchase is really with like meaningful interrogation and interpretation language that really honors the fact that we're relying on these assumptions. I mean, it would be nice if we could just easily attach some quantity to that cost and get that quantity like built into our models, but that's not, they may be realistic in some cases, but we really want a more general kind of approach. And that really is a more qualitative, hard process of justifying. So I'm just gonna just throw this up there for just kind of low hanging fruit for assumptions. So just like extrapolation, a lot of times people don't plot the raw data before modeling. So I mean, this is one where like extrapolation, if you're going to make any inferences between like 4 and 6 on the X scale, like that's all coming from an assumption, right? That's mostly assumption rather than information from data. And I have these two versions on here. The left one, the colors are indicative of groups. So this is like plotting data and fitting a model where there's a lack of independence. So you've got dependence in the data that's not accounted for in the model. So like those 4 observations over on the right that are really driving what that line looks like. Those are all related and probably should just be one observation, like aggregate to the unit, which is what's shown on the right. And so you can see, even from that assumption, if I assume all of these points are independent and don't account for the dependence, see how much narrower and falsely precise my inference is going to be. Right, so this is like really obvious ones that you'll like see in class, but just to kind of get us thinking about that a little bit more. And I think a really important point is that we're often taught that checking assumptions is a met or not met exercise, right? It's a box to check. Either they're met or they're not met. And that's not realistic at all. So there are very few situations where our assumptions are not violated. Like you can maybe go through like a really simple randomized experiment where the randomization was done and you're going to use a randomization distribution for inference. Like maybe you're like, okay, but that's really rare in practice. So we need to go into this knowing that our assumptions are violated. Like they're assumptions. That's like, they're not known. So a meaningful question is like, how severe are the violations relative to threats to the validity of our inferences, which is a hard question, but it's meaningful. And then the not meaningful question is like, are the assumptions met? Well, like you can answer that really easily. No, like they're never met. So like, what are you gonna do about that? It's really a completely useless question in practice. So at this point, like it might be asking like, okay, well, what's included in assumptions? Like I know all of those that I have to like put in my homework assignments, but like what else are we including here? And we're actually including a lot. So this is like the model assumptions that are, written down in the textbooks about a particular model. And then there's like everything else that's like backing up that we're putting into the whole process of collecting the data, using the model, and making inferences. So basically everything that we're assuming in giving those, in pretending those results are valid at the end. So this is like the decision to make a probability model to begin with, the mathematical assumptions that we've talked about, that there's no researcher errors or corruption. So we don't often think about that one, right? But we are usually assuming that there aren't any like big errors. Accurate reporting of decisions and methods. So transparency in methods is like hopefully pre-registration helps with this, but you're assuming transparency. All the design decisions, decisions related to measurement. So like what instrument are going to use and what are the potential issues of validity of the instrument? Can we even actually measure what we're pretending to measure, et cetera? So this is like really deep. Like there's so much there.
Oh, sorry to interrupt, but
Yeah.
we have a question.
Yeah.
Yeah, yeah, come up here and ask the, he's coming over here.
Hello.
Hello.
Hi. So
Hey.
I have like one question about like the assumptions that you make while you're making a model essentially.
Yep.
So, for example, if we're like predicting things, I know that we have two types of estimators. We have like a biased estimator and an unbiased estimator. And I think that using like a biased estimator essentially says that, you make some sort of assumption about the data that you're going to predict, and then you predict things based off of that. So my question essentially is that how do you decide on like the assumption that you're going to make about like the distribution of certain things in a biased estimator, if that makes sense?
For a bias estimate, I mean,
Yeah.
so yeah, I would say it's really not that much different than if you're going to use the unbiased estimator either. But
Mm-hmm.
you're, yeah, I mean, this is a really hard question. This is and you're going to look at the properties of of your outcome that you're going to
Mm-hmm.
measure. You're going to think about
Mm-hmm.
the design,
Mm-hmm.
definitely. Think about the results, and I think you're saying in a predictive way. So,
Yeah.
like that's um, this is like really to bring in, the most important thing is to bring in the context of the problem.
Mm-hmm.
So like I don't have a canned answer to that, because I would say it really depends on like all the characteristics of the data, the questions being asked, the decisions that are going to be made
Uh-huh.
afterwards, and like really trying to think about the whole thing, and like if these assumptions, and like how sensitive are your predictions
Mm-hmm.
to that assumption. So I
Mm-hmm.
mean, I guess that's like an obvious one that you can
Uh-huh. That
check a
makes
little
sense.
bit more.
And I guess like another question that I had is that how do you decide if an assumption that you make is like logical? Because I feel like
Yeah.
a lot of times if you aren't a subject ex like I feel like many times if you're a data analyst, you might not be like completely familiar with the type of data you're analyzing. Like let's say I'm like trying to analyze like food data, so the sort of nutrition that people eat. I feel like I can make certain assumptions when I'm doing an analysis,
Yeah.
but if I'm not a subject expert, I don't know if like the assumption I'm making is logical. So
Yeah.
how do you go about something like that?
Yeah, that's an awesome question. That's a really important question. And so this is not something that a statistician or a data scientist can typically do in isolation. So that's one of the problem. That's one of the behaviors in our kind of current scientific culture that has kind of siloed disciplines a little bit more,
Hmm. Hmm.
um, that creates problems. So yeah, you shouldn't, like that's totally fine that you don't know that, and that's the really the role of collaboration and reaching out to subject matter experts and working together. Like we can't really do this. Like what I'm
Hmm.
proposing you can't really do in isolation
Mhm.
as a data scientist or a statistician. So this is a
Mhm.
team. This is also to motivate like working as a team, and we can't keep separating data analysis from
Mhm.
all of the expert knowledge and
Mhm.
not even just the expertise, but the knowledge about how the data were collected, what went,
Uh-huh.
decisions went into the design, how
Mhm.
it's going to be used, what decisions will
Mhm.
really be made
Mhm.
after the fact. So like all of that, like so
Because
important. So
because
yeah,
I
that
feel
was
like
a great
I see a
question.
lot of machine learning like teams or like a sort of machine learning projects that are filled with like people who are good at math and who are good at like CS, who know
Yep.
how like the neural networks work. But more often than not, the problem that they're tackling, let's say it's in chemistry, physics, or like even a simple traffic related problem, like it's hard to like sort of know what will work or what won't work until like you talk to an expert. And I was just curious whether like people who work on those teams, whether they have like some way of like just bypassing that, or like is that something that we should just like no? Okay. I see. I think that answers my question. Okay, thank you so much.
Yeah, no, it's a great question. And it's definitely a huge challenge. And I know it is kind of a bigger challenge in the machine learning, some of the data science realms than it has been in my past work, because usually I am connected to the researchers in some way. But yeah, I mean, reaching out, even if you're in that situation of like being handed data as part of your job, really like lobbying for the importance of being able to connect with somebody who has that enough knowledge to help in it. Um, yeah, this is just a figure that I made for another talk, and really just like an idea. It's not important that you look at everything, but the main thing here is just like I tried to make the sizes of the rectangles kind of approximately to show the kind of importance of it in this like more like scientific process or decision making process. So we have this like big, like this huge thing of making inference, like the research problem's really important, the design and study, the collection of data, got all these assumptions. And now the next slide is just going to show like change the shape, the size of the rectangles to show what it feels like to me is actually kind of the emphasis given to each of these in practice.
Oh, we have another question.
Oh yeah. Oh here, let me just
Hi.
show this real quick and then I'll.
Okay,
Okay.
okay.
Is that okay? I'll just go
Yeah,
back
yeah,
and
that's fine.
yeah.
That's fine. Yeah.
Oops. Yeah. Okay. So here's the one how it should be, and then like here's the assumptions really small, making inferences like really small, like research problems design, and then math computing like huge, and statistical methods, right? So it's kind of consistent with the comment that was already made. Okay. Yeah. Next
Hi,
question.
Megan. Hi.
Hey.
I had a question, kind of trailing off of the previous the previous student's question, which was you mentioned something about like bringing different specialties together and trying to like what you're addressing is like trying to avoid assumptions when you don't have like sufficient information, right? So if considering that you're working in an organization with different skill sets of different people, how do you like bring all of these like different assumptions and ideas from other individuals and like incorporate that into like a data analysis? Like how do you like give these like cross-disciplinary teams like the right data? Like I don't know how to like phrase this question, but like
Yeah.
I just how do you like create something that is valuable to like a cross-disciplinary team?
Yeah, I think I see what you're asking. I'll answer and you can tell me. Yeah, I mean, I think that part of so one, we're not trying to avoid assumptions, but we are trying to
Okay.
meaningfully interrogate and justify them as best we can. Like it's never going to be perfect. Like we're going to do as much as we can in that realm. So
Mm,
and part of our job as data scientists and statisticians is the translation between the models methods that we're using and the scientific or research or whatever context. So I think really, there's no easy answer to your question, but it is really important to um, think of our role in that translation piece. And as part of that translation is having discussions about these assumptions. And you can start with the ones that are, you know, the ones that you learn in class, like the mathematical ones, and like start to get good at like, how do I talk about independence, the assumption of independence with different stakeholders? How do I translate that into real life words? And then, you know, if you really do have a team, I mean, it's awesome to like talk to different people who have expertise and like see where you have agreement and where you don't. And ideally you get people in a room together, and like, I'm this like kind of pie in the sky because it doesn't happen as often as we like, but yeah, that role, that translation is hard work and super important, and somebody has to do it, and we're the ones that are in the position to be able to do that. Does that
Okay.
kind of answer your question?
Yeah, so like basically the analyst analyst data scientist they're in charge of like translating the math and stats over to like the rest of the team.
Right, and asking questions then. So you're kind of translating this assumption into the context, right? And I'll give a little bit example later. And then you're getting their opinion about that. So you're not providing the opinion about the assumption, but you're trying to gather information, context dependent, to help justify, you know, whether you're gonna go with that assumption.
Okay. All right, makes sense.
Yep.
Thank you.
Yeah. Yeah, and a lot of it, I mean, we're gonna have to make assumptions, right? This isn't about not making assumptions. It's just about acknowledging the fact that we are making assumptions and like feeding that in. Yeah. Okay, well, let's see. What time is it? I should like figure out.
You still have like 30 more minutes.
Okay, yeah, I think we'll be fine. I have a couple of things I can skip in. I'm happy to have questions, so it's great. So this is a quote by Herbert Weisberg, who wrote a book called Willful Ignorance, which I really love. Anybody who's interested in the history of statistics and probability, I highly recommend this book. Like, and then the first couple chapters and the last couple chapters are just like really practical as well. But there is today a broad assumption that the quality of scientific research depends much more on methodology than on personal expertise. So our emphasis tends to be on training scientists in technique rather than, say, logic or creativity. So this primarily methodological conception of science has in some areas led to a plethora of technically sophisticated but uninspired and trivial studies. So just like something to, you know, it's just a little different flavor than what we're exposed to usually. And just like as part of this, it's like really important for us to realize what paradigms we're operating in. And so I'm just going to throw a few of these out there. I don't want a lot of the talk to be on these, but I just want to put them out there for you to think about later. So we tend to have, hopefully this won't come as a surprise to anybody, but we tend to have this dichotomania, this desire for yes or no answers. And that's just a human desire. But we tend to use statistical approaches to satisfy this. And that is typically oversimplifying scientific inference through over-reliance on statistical approaches, because we feel like they're there to give us this yes, no answer and kind of make life easy for us, which is not really what they're in place for. We really have this high value placed on perceived objectivity. So, you know, we don't want anything to look subjective. Like we want to, there's like a real strong incentive to basically back off anything that looks subjective. And so that's really counter to interrogation of assumptions, because interrogation of assumptions is going to be inherently subjective. Not everybody's going to come to the same conclusion about whether we should rely on a particular assumption or not. So, which relates back to the previous question. Philosophy and history of science are often viewed as soft topics, so like not directly useful to doing science. I think there's so much value and so much that we can learn from really, as any scientist still digging into philosophy and history of science. That's a whole nother talk. And then incentive systems, like, yeah, they're just often tied to statistical results. And that's like so built into our current paradigm and culture that it's really hard to shift things. So like, what are our responsibilities like as data analysts? So I kind of touched on this with the answer to the question, but it's not only to understand the layers of mathematical assumptions, but also to do like that translation, to also like struggle with other layers and how to assess them, and helping the people who have the expertise to actually do that. So, and that takes like this attempt to like wrap our heads around and convey it to others, that all the results, that our statistical results that we're providing, or our predictive algorithm results, like they are conditional on layers of assumptions. So, and the implications of this depend on context. Sometimes this is like a big deal, and sometimes not so much, but that conditional piece, so important. So like, what do I really mean by conditional in this situation? Like, just that when the results are conditional on assumptions, so this is like the model and all background assumptions I was talking about, it just means that the results can be trusted if those assumptions hold. Right? So that's really like this is kind of this is the foundation that we're operating under, and not really being honest about it a lot of times. So, and when you think about this, like that feels pretty unsatisfying. It's like ambiguous, it's like uncertain, it's uncomfortable. It goes against many of the things that people think they're getting from statistical analysis, right? Like, I want to use a statistical analysis because that'll make life feels like I got rid of the uncertainty by using it, right? Which is not the case at all. I quantified some uncertainty under a bunch of assumptions. So it does require dealing with even more discomfort around uncertainty, and that can be really, uncomfortable. So we really want to expand, like this idea of the, really takes expanding our idea of how we think about our other assumptions in there. So we're like really used to, you're probably used to at least thinking about results given like the data and the model. But our version of what a model is usually pretty constrained to that like really specific mathematical sequence that are written down. So like, let's like expand that to like the model and the other assumptions. And so this is like easy for me to write out. It's really hard to do, translate into interpretation and inferences, obviously. So we'll talk a little bit more about that. And then just to like reiterate, the danger is like this over reliance and overconfidence in results and conclusions, because you're presenting results and conclusions that are conditional on assumptions that are not met, and we're not really acknowledging that. So you know your intervals are too small, you know your p-values are too small if those are the things you rely on, or your other metrics for prediction are too good, or are too optimistic. So like what can we do to really count for that? So in my take is like, we want more, like our goal is more honest inferences, right? Like how can we really be more honest in this? And for now, that's like a shift in language and interpretation, and to really try to convey a scope of inference, which I mean like really coming back and thinking about, okay, like what scope of inference can I really justify and feel good about and trust, and scope of inference in a like wording way around my results. So there's a paper that I've been collaborating with authors, but it really comes from Greenland and others first, which is kind of going after the shift to unconditional inferences, which is a little confusing a little confusing wording to begin with, but I'm going to try to give a sense of what they mean by that. And so you don't have to read this, but this is the paper. It's just a preprint up there. It's not published yet. We're still kind of working on it. But to aid scientific inference, emphasize unconditional compatibility description. So it's Greenland, Raffi, Matthews, and me. Okay, I am going to read this one. So we provide arguments. This is a quote from the paper. We provide arguments and methods for reinterpreting statistics such as p-values and interval estimates in unconditional terms, which describe compatibility of observations with an entire set of underlying assumptions, rather than just with a narrow target hypothesis conditional on the assumptions. So emphasizing unconditional interpretations helps avoid overconfident and misleading inferences in light of uncertainties about the assumptions used to arrive at the statistical results. So like taking into account, like, are we overconfident and misleading? How overconfident and misleading are we based on the uncertainty in those assumptions? And so these include not only mathematical assumptions, but also, right, systematic errors, protocol violations, data corruption, like all of the things that you can think of that might go into it. So just to provide a little bit more, what we're really saying is to introduce assumption uncertainty. What we're really arguing for is to introduce assumption uncertainty into the primary interpretation of statistical results. So rather than just in this like limitation section, after you've already given the results that are all conditional on these assumptions. So it's not at all a change in calculations. It's not a change in methods. It's really just this change in interpretation. And yeah, I mean, as we operate now, conditional interpretations are really mute about the reasonableness of the background assumptions in the application context. So that's just kind of ignored. We put them out there, and then come back to it like later. But that part's never really read by most people, I don't think. So just like an example of like conditional versus unconditional statements. So a conditional statement, this is typically what we put in papers, etc., reports. If really you're saying, if this study is valid, I'm doing it for a drug thing. If this study is valid, then the drug is effective, right? So this is like, okay, so your statistical conclusion was that the drug was effective. And there's a lot of baggage there, but let's just say that. So this interpretation is given that assumptions hold. Typically, we don't say that if the study is valid part though, right? Like that's not even included though, but it is there. The unconditional version would be like either the drug is effective or the study is invalid, right? So one of the reasons that we might have got the conclusion that we did was because the study was invalid, not just because the drug is effective. So we just don't know which one of those it actually is. So starting to use wording that acknowledges the possibility that one of the reasons we got the results we did is because the assumptions didn't hold. So it's a little tricky, it's a little confusing to begin with, but hopefully that makes a little bit of sense. So just a little bit more on this, like conventional interpretation assumes things are known true when in fact we know they're not known or true. And when you realize that, you're like, well, what are interpretations then? Like, what are our conditional interpretations? Well, at best, they're an interpretation for a hypothetical world in which those assumptions are true. But that could be really far from reality, right? If we haven't done the work of kind of trying to assess how far it is from reality. And so this hypothetical quality of the results that we're providing from statistical analysis or algorithms is really typically ignored or overlooked when the background assumptions are left out of interpretation, which again just makes results seem more definitive and trustworthy than they really are. So, we're not calling for different math. We're not calling for, I think it's really is just like this logic and language. And so this kind of comes back to an earlier question, like we don't need, as statisticians, data scientists, it's not our job to make the final call about this, but we need to work to communicate and support more honest statements. And that is that role in translation and working with others, which can be challenging to find those people to work with. Yeah, I kind of said this earlier, just like the tests are not, checking assumptions isn't a met or not met thing. And this challenge just rephrased, like, how do we translate questionable or highly influential assumptions into statements about trustworthiness or reasonable uses of results and conclusions? So it's kind of a lot of words, but it's really that translation piece. Like we have uncertainty in these assumptions, and how do we filter the fact that these assumptions are not true, not known, into our interpretation at the end, so that they're not just lost in that fact isn't lost. Okay, so here, this is actually from the paper, the Greenland et al. Paper. They use an example in the paper about serotonergic antidepressants. And this is an example that this is wording from Greenland about how he would provide caveat language. So any clinical advice regarding the continued use of serotonergic antidepressants in pregnancy will need acknowledgement and quantification, if possible, I added that, of the uncertainties not captured by the statistical results, as well as of the potential costs and benefits of switching to available alternative medications. And so it's like, it sounds like a fairly typical limitations kind of phrase, but this is going to come with the results, like in the results section and not separated. And it's trying in some ways to honestly highlight limitations of the statistical results and say, like, don't make a decision based on these without acknowledging the fact that there's more uncertainty. Oh, sorry, I repeated a slide by accident, or repeated part of it. So this is really just this last part, the last one on there. Can we pay for assumptions more qualitatively? And so that's like where I think the checkout has to come right now. Like, where the cost is that it takes a lot of energy and effort and time to qualitatively kind of go through this more meaningful interrogation and justification process. Okay. And so in all of this, in this like interrogation process, in this like checking assumptions, we're always going to have to ignore things, right? Like, we can't account for everything. So it's just like it's a helpful part to just realize, like, in order to use the probability models that we use, the algorithms, we have to be willing to ignore things, but hopefully we're willingly ignoring things and making that decision, as opposed to unwillingly ignoring. So Weisberg says, mathematical probabilities and the statistics used to estimate them depend on willful ignorance. It is only by ignoring certain specific considerations pertaining to the event or statement in question that a mathematical probability becomes possible. I mean, in a lot of cases, we're taking these real life situations and we're turning them into, we're relying on games of chance theory, right, to like help us go forward, which means we have to ignore some things in order to get there. And unfortunately, life gets harder the more we know, right? This is like, we always think that the more we learn about something, the easier life's going to be, but that's never the case. It's always harder, in my opinion, or in my experience. So, and this is an important one for assumptions. So like, the more we're ignorant of, and this is like contextually, the easier it is to usually trust the assumptions. And this applies both to statisticians and subject matter experts. So, okay, so for like an example, let's say we have data on 100 participants, and we'll just use the drug example. We've got like 100 participants in each group, like some treatment applied to them. And if that's all you know, that I have 100 subjects in each group, and there's no way I can get any other information about those subjects, about what happened. Let's say we know they're randomly assigned. We'll say, like, we know there was random assignment, simple random assignment. And then you can go forward with a pretty simple analysis and probably feel okay about it, right? And like, you would justify, part of your justification for that is like, well, I don't know anything else about these subjects, so here's what I'm gonna go ahead and do. But now if I tell you, oh, well, these subjects are between the ages of 18 and 50, they're female identifying patients only. Oh, well, okay, so you've got that information. Now you're like, ooh, well, how do I account for age? Like, how does age relate to treatment effects potentially? And like, what else is going on? And then suppose I say, oh, and like, they're from 3 different clinics from these 3 different regions in the country. And, oh, they have like different underlying conditions. And, oh, well, I actually recruited these subjects by, some of them I recruited from the clinic, and some really answered an advertisement, right? So like, the more information that I give you in this, like, the more you've got to think through in terms of like, oh, wow, now the assumptions I was going to rely on when I didn't know anything, now all of a sudden it's like, oh, well, I don't feel comfortable doing that. So, or I'm going to have to like do a lot of justification. So, yeah, so I go through this as a exercise in just like acknowledging, but also, it's hard. It is hard. This is just like a cartoon that I left in there. So enlightenment sounds okay, but I've decided to go with willful ignorance instead. So I feel like this is where we always end up, basically, with statistics and data science stuff. Okay. Yeah, just like a couple of final thoughts. I mean, I'm kind of repeating, but how can we honor usefulness of results? So I'm not saying we shouldn't use the results. Like, I don't want to be like, sometimes it can come across really pessimistic, but just wanting to use results and value the limitations and creativity. So we can think about our statistical results as some information as part of the process of making decisions, but we shouldn't put all authority onto those given what assumptions are underlying it. And so how can we as statisticians and data scientists help avoid putting more BS into the world under the guise of trustworthiness, the perceived trustworthiness from statistical models? And Fisher, so one of the most famous people in the history of statistics, the history of science has suffered greatly from the use by teachers of secondhand material and from the consequent obliteration of the circumstances and the intellectual atmosphere in which the great discoveries of the past were made. And, I think this is always an important thing to keep in mind. Just like, what have we lost through it? Oh yeah, I forgot I threw these on the end. This will be, yeah, I just think acknowledging that our educational journeys in this day and age focus on doing statistical analysis and doing algorithms and implementing algorithms and getting results, and less on really thinking about what we're conditioning on. And an important place to start, just asking the question, like, what am I already taking as given before I even start in any algorithm or analysis, and recognizing that that depends on the norms of our scientific culture right now. And I think I'm gonna skip through that so we have more time with questions. But important, I mentioned this throughout, we're operating within a culture, and that's really important to recognize. We have defaults, there's assumptions that people are just so used to using that we don't even question. And that's kind of one of the big problems. So recognizing and admitting that this science and decision making is seems much harder to do than in other social areas. Like, we're humans, all the human things are going to come into this just as they do in other parts of life. And how we do science, I mean, just keeping in mind, like, how we do science is not a finished business. Like, sometimes it's easy to think like, oh, we know exactly what we're doing, we have the scientific method, but it's not that simple. And as soon as you start reading about more philosophy of science, or like if this spurs your interest to do so, like, you'll start to really kind of feel that. Oops. Well, I'll say thank you for your time, and then I'll go ahead and just put up, these are just some references that are just fun books. So if people are interested in just kind of starting to see what's out there in terms of other ways of thinking about things. So thanks so much, everybody, for your time, and I'm happy to take a few more questions if we have time.
Megan? You have to come up here, and
She's not here.
not from back. Yeah, you got to come up. The mic isn't working right now, so you have to come up and ask the question. He's coming down to ask a question.
Okay, awesome.
Yeah. I mean, so another question was about like unconditional assumptions. Don't you need like I'm sure you know this. Like what is the relationship between the like asking conditional assumptions and like precision of what you're trying to address? Because I imagine if like the point of conditions is just to simplify like the potential outcomes, to reduce the potential outcomes. So if you make everything like unconditional, for example, then like the potential outcomes just become infinite. So
Yeah. Yeah, so we're not saying that you're doing that. So you're it's in the interpretation. So it's conditional interpretation, unconditional interpretation. So you're still going ahead and using whatever assumptions, conditions that you need to make the problem tractable and to be able to do it. But then it's just simply acknowledging the fact that those results that you're reporting are conditional um, on all of those assumptions. So the unconditional part is really tricky. Like I had a hard time like wrapping my head, like getting to the point that I feel comfortable with that. But so basically it's saying like, now we're going to say, well, in like the case of a hypothesis test, right? Just like a really simple hypothesis test. Like we tend to make a conclusion like, okay, well, we're rejecting the null hypothesis, for example, if you want to go like super simple. But you could either be rejecting the null hypothesis, or it could be rejecting because of some other assumptions. Like it's not necessarily the null hypothesis. Like that really constrained version is just conditional on all the other assumptions. Then we can narrow it to like what's going on with H. But really all these other assumptions are there. So can we use language that is actually acknowledging, well, it could be that that null hypothesis given the model is wrong, or it could be that the whole model's wrong. Right? Like, so it's really just that like opening up the language and interpretation and like bringing that in rather than keeping that hidden once you get to the interpretation stage. So
Right.
that's what's meant by unconditional in this case.
Yeah, there's just like I think we're just like, then this is just my thought. Just the way we learn to like think and talk, it's all like conditional. So it's just really hard to read, and I guess that's why people don't like operate in unconditional like assumptions.
Right.
Yeah,
I
it's
mean,
interesting.
we can never get to unconditional, right? Like that's not possible, like just like what you said. But we're trying at least to acknowledge the conditioning. So like maybe that's a better, like that's a better way to say it, just like you said. We're always conditioning. And how can we be more honest about what we're conditioning on?
Okay. Okay, yeah, that makes sense. Thanks.
Okay, yeah. Thanks for the question.
Yeah, so I actually have a question.
Yeah.
Like you touched on kind of like the paradigm of incentives. Um, right? And this is probably especially in academia where, researchers are like heavily incentivized to get like a certain result, right? Within their research, right? Obviously, you want to get like if you're doing a study, you want to get an outcome with a p-value below 0.05. But that creates like a huge filter effect where, we don't see a lot of studies because they might not be statistically significant, but they still might provide like certain unique insight. I was kind of wondering if you had like any thoughts on that and why that's like a big issue.
Yeah, no, I have a lot of thoughts on that. But so first I'll just acknowledge like yes, like like our statistical results are tied to our incentive system in science, particularly in academia. And that is a huge problem, right? So it creates, like you said, a bias in what results are actually published, like what we're actually seeing. And also back to like what I talked about today, it takes away from motivation to honestly address assumptions, right? Because if I use that unconditional inference, if I use unconditional interpretations, and the paper next to me has the same p-value, but they're not using them, their paper is going to sound much more definitive and sell a lot better, right? So there definitely is this like, and that's kind of like the paradigm that we're in right now. It's really hard to gain momentum to do this. So one of the things that I think that I'm trying to put out there right now, actually, I just submitted a paper, which hopefully will be published in a special issue, is this idea that what I think we need to do is put a place in the workflow. So this could be like any data analysis workflow in the very beginning where you're tying the decisions that are going to be made post analysis. So that could be even just whether I'm going to publish, like, am I going to submit this? Like a real honest thing to the quantitative so it's called a backdrop, I call it. So it's like tying it to the actual scale of measurement or scale that our estimates are going to come out, and actually going through hypothetical scenarios of like different places, different intervals that we could get, for example, and really thinking about, okay, well, if I get an interval here relative to the actual scale, context dependent scale, then this is the decision I would make. If I get this interval, then this is the decision I would make. So, and pre-specifying that. So like actually documenting that and pre-specifying it, I think is really, and there has to, if we could get incentives for doing that at the beginning, like we've had, like there are incentives for pre-registering studies now for sure, because you definitely have a better chance at getting published post study if you pre-registered before, even if you have a large p-value, right? So like that has like filtered in. So I know that this might be a confuse. I guess I should just like say it more generally of like an a priori way to like really tie context to the results and model and decisions that are going to be made afterwards, I think is really important.
Yeah, that
Thanks.
makes sense. Thank you so much.
Yeah.
I think we're just hitting up on time.
Okay.
But thank you so much for taking the time to come here. I really enjoyed the talk, and I'm sure everyone else here did as well.
Thanks so
So
much
thank
for
you so
inviting me.
much for being a part of our event.
Yeah, thanks. And I hope it's not like too overwhelming. Really, my goal of this whole talk is just to like get you guys thinking about it, just to like have it there as like a background in the back of your head, but not to like make everything seem impossible.
Yeah.
So thanks everybody.
All right. Well, I hope you have a great rest of your day.
Okay. Bye everybody.
Bye.